Welcome back to Curiosity Compass. Imagine a future where libraries are the size of sugar cubes, where entire collections of books and knowledge are condensed into something you can hold in the palm of your hand. Entire film archives fit in your pocket. This isn't science fiction, it's a glimpse into the future of data storage. It's the promise of DNA data storage, a revolutionary concept that could change everything we know about storing information. We're talking about using the building blocks of life, our very own DNA, to store the vast digital information of our world. DNA is life's blueprint, a code that has been perfected over billions of years. It holds the instructions to build and operate every living organism, from the tiniest bacteria to the largest mammals. Now imagine harnessing this incredible storage capacity to hold our digital treasures, our photos, our music, our knowledge. The possibilities are endless. It's a revolution in the making, a paradigm shift in how we preserve our past and carry it into the future. This technology could redefine our relationship with data. The digital age has brought an explosion of information, a deluge of data that grows exponentially every day. We generate unimaginable amounts of data every second, from social media posts to scientific research. But our current storage methods are struggling to keep up. Hard drives and data centers are becoming obsolete. Hard drives fail, data centers consume massive energy, and the environmental impact is significant. DNA offers a solution, elegant and powerful, with the potential to store vast amounts of data in a tiny space. It's time to explore the potential of this remarkable technology, to unlock new possibilities and redefine the future of data storage. But first, don't forget to hit that subscribe button and stay tuned for more epic content on mythology, captivating stories, fascinating facts, and ancient wisdom. And leave us a comment on your favorite topic. Let's explore together. DNA is incredibly dense and compact. Just a single gram of DNA can theoretically hold up to 215 petabytes of data, which is an astonishing amount. That's equivalent to millions of high-capacity hard drives crammed into a space smaller than a grain of rice. Imagine the efficiency and space-saving potential. Think about that for a moment. The implications are mind-boggling. This remarkable storage capacity comes from DNA's unique structure, which is both elegant and efficient. It's a double helix, a twisted ladder with rungs made of 4 chemical bases: adenine A, guanine G, cytosine C, and thymine T. These bases pair up in a very specific way. These bases are the letters of DNA's code, forming the language of life. By arranging these bases in specific sequences, we can encode digital information, much like writing a book or programming a computer. Essentially, we're translating the ones and zeros of computers into the language of life, bridging biology and technology. This allows us to store an immense amount of data in a minuscule space. Imagine the possibilities for the future of data storage and beyond. So how do we actually get data into DNA? It's a question that bridges the gap between biology and digital technology. It's a fascinating process that starts with digital information, the kind we use every day on our computers and smartphones. This digital information is made up of binary code, the ones and zeros that make up our files, images, and videos. This binary code is then converted into a DNA sequence, a process that involves sophisticated algorithms and precise calculations. Think of it like translating a book into a different language, where each letter or word has a corresponding DNA base. Each digital word is matched to a specific sequence of DNA bases, such as A, T, C, and G. This sequence is then synthesized in a lab, creating artificial DNA strands that hold the encoded data, much like a hard drive stores files. The synthesized DNA is then stored in specialized containers. It can be dehydrated for long-term preservation, ensuring the data remains intact for years, even decades. To retrieve the data, the DNA is sequenced using advanced machines that read the order of the bases. This sequencing process reveals the exact order of the bases, which is crucial for accurate data retrieval. The sequence is then decoded back into digital information, making the data accessible again, ready to be used just like any other file on your computer. Our current storage methods are fragile. Hard drives crash, magnetic tapes degrade. But DNA is remarkably durable. Think about fossils. They contain DNA fragments that are millions of years old. Under the right conditions, DNA can last for millennia. This makes it an ideal storage medium for long-term archiving. We could preserve our history, our knowledge, and our culture for future generations. Imagine a world where ancient texts are no longer lost to time, where historical records are preserved in their original form. DNA data storage has the potential to revolutionize our understanding of the past and safeguard our heritage for the future.